Hi, welcome to another video on differential equations. So today we're going to be going over the Bernoulli differential equation. Bernoulli was definitely a really smart man. Came from a family of very distinguished mathematicians, and he has a lot of work in physics and in math. So today we're going to be going over this differential equation, which will be in the format of y prime plus p of x, y, and that's going to be equal to a function times y to the n. And I should point out that this will be non-linear. Okay, so we'll start off with an example on how to solve one of these differential equations. So we'll start off with something that looks like this. Alright, and we want to recall what the standard form looks like. So we really want to get it to look like this. Alright, so this is the standard form, and we will attempt to make this equation look like the one in red. So how will we do that? Well, I'll start off with dividing every term by x, and I will get y prime minus 1 plus squared, and this will be nonlinear. Okay, so our next step will be w equals y 1 minus n power, and we'll get okay, and notice that this is linear. We're going to go ahead and plug in all this information that we have from our equations into these two. Okay? So if we notice, our n is equal to 2, our p of x is equal to negative 1 plus x divided by x. And I'm getting this information from, notice that our n is 2, and our p of x is going to be here. I'm sorry, not the y. Everything but the y. Right? Okay. And f of x will equal 1. Alright, if we plug in all this information into that equation, we'll get w prime plus 1 plus x divided. Nope, I'm thinking ahead. We'll have And we just took all this information we have here, plugged it into this equation, this format that we have to have, and we'll get this. Okay. All right, so now we'll have to find, well, using this equation, we'll find mu equal to e to the power px dx, where mu is equal to e to the integral of 1 plus x over x dx. Mu will equal e integral of 1 over x plus 1 dx. What I did there, I just separated the terms, because then it would look like this. It would be mu equal to e to the natural log of x plus x. And then you'll get mu equal to x e to the x. Okay, and then what we want to do with our mu is get it in this format, which looks like x e to the x w prime. And since that's being multiplied, that is going to equal negative x e to the x. Previously, our f of x was 1. So now we'll integrate both sides. Get x e to the x w is equal to the negative integral of, plus c. And what we could do here is divide everything by this term. U2 plus C. Okay. You notice that'll cancel. This term will cancel with this, and then we'll be left with an x when we divide by those. So we'll see that. That's going to equal w is equal to negative 1 plus 1 over x plus c over x e to the x. And in this case, we have our w equal to y 1 to the n. So we want to change our w back into terms of y. Okay, so our n previously was 2, so we'll have y to the 1 minus 2. W will equal y to the negative 1 power. So we're going to go ahead and put that in for w. And that is how you solve that differential equation. Alright. So if you want to go ahead and do another problem, we'll solve this differential equation to the indicated initial condition. So this problem will have an initial condition where y1 is equal to 1. Okay, so I'm going to go ahead and change this dy dx to y prime just so it looks a little nicer. You don't have to. It's just a preference I have. And I'll go ahead and divide everything by 2. We get y prime minus 2xy is equal to negative. And with this y squared, you have to be very careful because here it looks like the n is equal to 2 if you look at it here. However, you have to get this equation into the correct format. So to do that, you're going to have to bring that y squared up into the numerator, and that's going to change that to negative 2. So now the n is negative 2, and this is the correct n. Alright, so now that we have this equation, I'd like to extract all my components that I need. For instance, I'll need the n, which we said was equal to negative 2. The p of x is equal to negative 1/2 2x. And our f of x is equal to negative x over 2. And I simply got all these pieces of information from here. And this will be used once we need to plug in that certain information. I may even find what my w is. And this is why the n, getting the right n would be important, because we have y minus 1 minus a negative 2, which we get y to the 3rd power. So that's our w. And we'll go ahead and put all this information into this equation. Okay, so we'll have w prime plus a 3 to the negative 1/2 for x times w being equal to negative 3 over 2x. All right. You can go ahead and distribute that 3 if you'd like. Okay. So, our new information is going to come out of this equation, right? And our new p of x will equal to negative 3/2 over x. Our new f of x will equal to negative 3/2 times x. So be very careful when you're trying to get the information, because this p of x will be needed here, and this f of x will be needed here, and the n will be here, to get this new equation. And then you'll need to extract these new information, these new pieces of information. Okay, so we're going to go ahead and find out what our mu is equal to, which is just e to the integral of px, which in this case was negative 3/2 over x times dx. That's going to equal e to the negative 3/2 ln x, which then equals to x to the negative 3/2. And if you don't know how I got that, I'll just go back and put in one extra step. I'll bring this leading coefficient into the numerator. I'll have ln x to the negative 3/2 power, and that e and the natural log will cancel, and the x to the negative 3/2 will remain. Alright, so that's what mu is. And so we'll plug this in, equal to x to the negative 3/2 times negative 3/2 x. Alright, so we want to isolate our w. So what we'll do is integrate both sides. And when we do that, that derivative cancels out, and we'll just be left with this equal to negative 3/2 okay. And the integral of that piece will be don't forget your constant. These 2's will drop out. And then we'll get so 1/2 plus c. Like I said, we want to isolate our w. So we'll divide by x to the negative 3/2 power. Okay, that'll cancel there. And what we'll be left with is alright. If you don't recognize this, you could bring that to the top and you could simplify that. All right. So this is our equation, and we said before that w was equal to y cubed. So plus c to the x3 halves. Well, we'll use our initial condition. When y of 1 is equal to 1, we'll have 1 is equal to negative 3 plus c. Add the 3, and we'll get that c is equal to 4. So we just use the initial condition to solve for that constant, and we'll go ahead and plug it back in. And that will be your answer. All right, thank you for watching. I hope that helped.